The application for differentiation is to apply on the rate of change. Alright, okay. So for the rate of change, generally you need to use chain rule, usually. Alright, when you want to solve the problems related to the rate of change. Alright, and then the rate of change usually refer to the rate of change of the variable with respect to time. So when you see that with respect to time means that generally your symbol for the rate of change will be something over dt, such as something like dv over dt, okay, or area dA over dt, and so on. It is with respect to time. Therefore, usually it will be a dt at the denominator. All right. Okay, then again, as what I mentioned just now, we are using chain rule to find out the rate of change, right? So usually it's like that. If you want to find the dv over dt, okay, then you need to form the rate of change yourself. It will be dv over something multiplied with something over dt. So the something here actually depends on what do you have in the question itself. All right, so this something should be the same as dx, dx, dA, dA, and so on. All right, so please take note on the formula for the chain rule. Okay, so now when you are having the variable which is increasing, then the rate of change will be positive. If let's say it is decreasing, then the rate of change will be negative. So this is quite important because if let's say in a particular question, you realize that oh, that particular variable, the value is decreasing from time to time. So that means when you substitute into your calculation, right, that particular rate of change should be a negative value. Remember that. A lot of students forget about it. Okay. All right, so these are a very simple detail on the rate of change. Nothing much we can talk about it. All right, so maybe you can discuss a few examples and see how. Right, so let's have a look for example 16. Okay, they give you an equation here. Calculate the gradient of the curve at the point where x equals to 1. So they are talking about gradient of the curve. All right, so this one you learned it before, right? The gradient of the curve is dy dx. All right, okay, so dy dx, if you follow the steps, you do the differentiation on your own. I'm not going to write out the steps here. You should be able to do it yourself. Your final answer for dy dx should be 12 over 5 minus 2x squared. All right, and then they are asking for the value of dy dx when x equals to 1. That means you also have to substitute the value x equals to 1 into the equation, and finally you will get 4 over 3 for the value of dy dx. All right, so this part 1 doesn't involve any rate of change yet. Okay, right, then now we continue further. Okay, part number 2, a point with this coordinate move along the curve in such a way that the rate of increase. Okay, so you see the rate of increase tell you that the value will be positive. Rate of increase of y has a constant value of 0.02 units per second. Okay, so if you look at this sentence itself, they are giving you extra information. The rate of change for y over dy over dt, rate of increase of y, so it's dy. And then I told you already the rate of change of something, right? It is always over with respect to time. So dy over dt equals to increase, means positive 0.02. Okay, then what they want? Find the rate of increase of x when x equals to 1. So they actually want you to find out the value for dx dt. So they ask you, what is the value for dx dt? Okay, so now you will start to get the value for dx dt. You need to form the chain rule equation first. It will be dx over something multiplied with something over dt. So what do you think that the something that you can use here? So you can always refer to the question. So your question now just only ask you to find dy dx, and then here you're having dy dt. Therefore, you can actually try to consider dy dt here. Right, then this one is dx dy. Okay, all right, so now substitute the value of dx dy. This is dy dx. So to substitute the dx dy, that means you also need to make the value upside down also, which is 3 over 4. Okay, and then multiply with dy dt. The value that you get just now is 0.02. And after this, you will have 0.015 units per second. All right, so this is generally a very general question, all right, about the rate of change. All right, so you need to know how to form the chain rule correctly, and then the rest of the thing, mostly you can get it from the question. So it is actually not hard. All right, okay, so this is what you have for the rate of change equation. Okay, maybe you can proceed with another example which is slightly harder. Yeah, slightly harder one. Right, so we continue to example 17. Okay, so you are having a spherical balloon. So it is a sphere inflated by a machine which pumps in air at the rate of 15 cm cube per second. Okay, so you see the keyword rate. All right, so the air is pumped in. So for this sentence, I feel like I want to write out an equation for it so that I can use it later. All right. Okay, when you pump in the air, the volume is increasing. All right. So the value here, 15, should be positive. Okay, so when you talk about the volume, cm cube, that means when I write out the symbol, it should be dv over dt. All right, equals to 15. Okay, it's positive 15 because you pump in the air into the balloon. So that means the volume is increasing. Okay, then what they want you to find? Find in cm per second, correct the two significant figure, the rate at which the radius is increasing. Okay, so they are asking for the rate of radius increasing. So they are asking for dr over dt equals to 1. They are asking for this. Okay, when r is equals to 10. Okay, all right. So this is what they want for part number 1. Okay, so now when you want to find dr dt, it will be dr over dt equals to dr over something equals to dr over something multiplied with something over dt lah. So we are talking about the something here. So again, what is the something that you should use here? You should use dv dt, right? So let me say it's dr dv. Okay, then now I don't have dr dv in this question, so I need to find out on my own. Okay, so r is radius, v is volume. So you need to think of one formula that involve the volume and radius. Right? So what is the formula that involve the volume and radius for a sphere? Okay, so what is the formula of volume of a sphere? So I hope that you can recall it a bit. The answer is 4 over 3 pi r power 3. So all this information, if can, you try to go and do some simple revision on it. The volume of a sphere, the surface area of a sphere, and so on. Okay, all right. So this is what I have here. So v and r is in one variable already, so you can already find out dv over dr. So what is the dv over dr here? It will be 4 pi r squared. Okay, then now I start to find out the dr over dt. So dr over dt is dr over dv multiplied with dv over dt. Okay, so what is dr over dv? So you have to make 4 pi r squared upside down. It will become 1 over 4 pi, and then the r substitute with value 10. Why I need to substitute with value 10? Because here they told you the r is equal to 10. They want to know the rate. So you substitute r equal to 10. dv over dt is 15. Right, so continue from here. You try to press the calculator and get the answer, which is 0.012 cm per second. To me, the rate of change, the unit is quite important, so you can try to write it up. Okay, so this is part 8. I think it's not hard also, right? Okay, then maybe you continue to part number 2. Okay, so they say once inflated air is released from the balloon at the rate of 20 cm cube per second. Okay, so after the balloon is fully inflated already, okay, so we don't consider about pump in or pump in anymore. Okay, because it is inflated, then now I release the air from the balloon. So we talk about release means that the air comes less and less, right? So it is decreasing. Therefore, when you write out the symbol here, it should be negative value of 20. Okay, so again, we are talking about the volume, right? So it will be dV over dt, which is equals to negative 20 now. So please remember this negative sign, because if let's say you are not doing it correctly, you forget to put the negative value here, later your calculation will be wrong. Okay, so this is quite important. Right, so what they want you to find the rate at which the surface area is decreasing when R equals to 10. So they actually want you to find out the surface area dA over dt equals to what? Okay, then when R equals to 10. Alright, so this question will be a bit more complicated. Right, so maybe we have a look first. Okay, they want you to find out dA over dt. Okay, so it will be dA over something multiplied with something over dt. Okay, so what is the something that I should use in this equation? So you see that I'm having dV over dt now, right? So this one should be dV. Okay, now the problem is I want to get an equation that involves V and also A. That means the volume and also surface area. Alright, so there are two ways to solve it. You can really write out the equation up, volume and also with surface area one. Alright, this is the first method. Don't want, if you find that it is very complicated, then for this particular term, you apply the chain rule for another time. Okay, so what I will show it to you is something like this. Volume and surface area, right? So again, volume. So for volume, sphere volume is 4 over 3 pi r cubed. So like what you tried just now is you can get dV over dr, which is equals to 4 pi r squared. Okay, and then what's the surface area formula for a sphere? Okay, so you should have 4 pi r squared. Okay, some students, they will substitute the A into this equation. They combine V and A together. They make the R disappear, and then they make the V and A in the same equation. Can also, that's one method, all right? Then, but for me, I found that the R will have some fraction power, so I don't like. Okay, so I will want to keep it simple. What I do is like, I find out differentiation for these two equations separately. Okay, so A, I'm having dA over dr, which is equals to what? 8 pi r. Okay, all right, then now I want to find out dA over dt. So as what I mentioned just now, we are having dA over something multiplied with something over dt. So the something in the question is dV. So I want to have dV here. Okay, then I don't have any equation with dA dV. I have dV dr, dA dr. So what can I do now is I will want to try to split this one. I want to apply this one with chain rule another time. That means I will have dA over something multiply something over dV. So what is the something that I can use here? I can use dr here because I'm having dV dr and also dA dr. And see that or not? So I apply chain rule for 2 times in this question. Because I don't want to change B in terms of A, the equation B in terms of A, because the power for this whole equation later will have a fraction, so I don't really like. Okay, so I will just keep everything as simple as possible. Okay, so when I apply it for the second time, then I can start substituting the value. What is the value for dA? What is the dA dr? dA dr is 8 pi r, right? So you put in 8 pi, r is a 10. Multiply with dr over dV. So you make this one upside down. you have 1 over 4 pi 10 square. Then multiply with dv dt. In this particular question here, it is negative 20. So you substitute it with negative 20. Alright, so again, it is very simple. If you press the calculator, straight away you will get negative 4. Surface area, the unit should be cm squared and then per second. Alright, so for this particular question, it is a bit special because of you use the chain rule for 2 times. Alright. Okay, so that's all for the video for this part, which is about the rate of change.